Exponential equations appear everywhere, from population growth to compound interest. Often, the variable we need to solve for is tucked away in the exponent. Today, we will master two powerful strategies to isolate that variable and find the exact solution. When the bases don't match perfectly, like 2 raised to a power equaling 10, we can't just guess the answer. We need a mathematical tool that undoes the exponentiation. That tool is the logarithm, which brings the variable down to earth. By definition, a logarithm asks the question, to what power must we raise the base to get this number? Understanding this relationship is the first step in converting complex exponential forms into solvable linear equations. The most critical property for solving equations is the power rule. It allows us to move the variable from the exponent position down to the front as a coefficient. This transformation makes the equation much easier to manipulate algebraically. In practice, we usually use the common log or the natural log because they are readily available on every scientific calculator. Both work perfectly for solving equations, provided you apply the same operation to both sides of the equality. Before applying logarithms, you must ensure the exponential term is alone. If there are multipliers or additions outside the base, move them to the other side using standard algebraic operations. Isolation is key to a clean start. Once isolated, we apply the logarithm to both sides of the equation. This maintains the balance of the equality while preparing the exponent to be moved. It is the mathematical equivalent of taking the square root to solve for a squared variable. Let's solve 3 to the power of x equals 20. We take the log of both sides, move x to the front, and then divide by the log of 3. This gives us an exact expression for x. When the base is e, the natural logarithm is the most efficient choice. Since the natural log of e is exactly 1, the left side simplifies instantly to just the exponent, 2x, making the algebra even faster. After simplifying the natural log, we divide by 2 to isolate x. This shows the versatility of logarithms across different bases. Whether using base 10 or base e, the logical steps remain the same. Sometimes, an algebraic solution is difficult. In these cases, we use a graphing strategy. By treating each side of the equation as a separate function, the solution is simply the x-coordinate where the two lines intersect. On a graphing calculator or software, you can plot both equations and use the intersect tool. This visual approach is excellent for verifying your algebraic work or solving equations where the variable appears in multiple places. If the exponent is an expression like x plus 1, keep it in parentheses when moving it to the front. You will then divide by the log of the base before finally subtracting 1 to isolate x. To recap our algebraic strategy, first, isolate the exponential term. Second, apply a logarithm to both sides. Third, use the power rule to bring the exponent down. Finally, use basic algebra to solve for the remaining variable. Remember that logarithms and exponents are two sides of the same coin. Mastering the transition between these forms allows you to solve growth and decay problems with precision and confidence. Try this one, 5 to the power of x equals 125. Using our steps, you'll find that x equals 3. Thank you for joining this lesson on exponential equations. Keep practicing, and we'll see you next time. Generated by Vision Solve AI.